Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faisal bin Muhammad YUSOF. My metric number is 1181795. First of all, I would like to present about introduction of fiber optics. So, fiber optics is a branch of applied science and engineering concerned with the design and application of optical fibers. Nowadays, this fiber optics become an important component that being used in our life, especially in the communication system. Before the presence of this technology, which is fiber optic in the communication network, the copper cable has been utilized firstly in the data transmission since the development of telephone in 1876. However, as the time goes by, the demand for the communication got increased and the demand have reduced the usage of copper cable due to variety of reasons, including poor bandwidth, short transmission length, and inefficiency. Fiber optic is a new method used in the communication network where the video, voice or data is delivered in form of light through a glass or plastic fiber. It is technology that employs light pulse to convey data from one location to another via an optical fiber. Furthermore, the reason why the fiber optic is more preferable nowadays in the communication system because it allows transmission over greater distance and at higher bandwidth or data rates than other kinds of communication network. Optical fiber are construct of a thin glass core with a diameter of 10 until 100 micrometer, and the two types of dispersion in optical fiber are intermodal dispersion and chromatic dispersion. Intermodal dispersion happens because of distinct light rays pass through a multimode fiber at various speeds. As a result, light dispersed due to early arrival and sometimes late arrival at the other end of the fiber. On the other hand, chromatic dispersion is caused by the spectral width of emitter, which controls the number of wavelength released. So that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, let's move to the methodology part. Okay, for this methodology part, where this part will show you how to stimulate these experiments. Okay, this is the circuits that we construct based on the given components from the lab sheets for the single mode fiber. Okay, first of all, what we need is the software itself. We need to install the software to the PC first. Okay, next we need to open the OptiSystem software and create a new project by clicking the new project buttons on the taskbar, on the upper side of the taskbar. Okay, next we need to find the components to build the single mode fiber. According to the lab sheet, we need the components as below. So the components that we need is the user defined bit sequence generator, next the optical Gaussian pulse generator, next the Fox 1x2 Fox, optical power detector, time delay, clock recovery, optical time domain visualizer, optical spectrum analyzer, dual ports optical time domain visualizer, and last but not least, the components that we need is the dual port optical spectrum analyzer. Okay, after selecting the components that we need for these circuits, we need to arrange and connect the components as the figures below that we show in this figure. Then before the simulation starts, we need to set up a few parameters. First, we need to set the bit sequence generator, which is we have to set from the default bit to 01000000 as in the lab sheets. Follow the lab sheets. Okay, seconds, we need to change the sequence length to 16 bits. This mode of changes will allow the injection of the single pulse. Okay, next, the third, we need to disable the mode such as attenuation mode, attenuation effects mode, third order dispersion mode, and self phase modulation mode in the optical fiber. Okay, furthermore, we need to increase the simulation accuracy. What we need to change is to change the 16 bit to 226 bit from the layout parameters. Okay, next we need to, after we finish setting up the parameters, It's time for us to simulate the graph. Okay, last but not least, we need to generate what we need is we need to generate the graph from the circuit configurations and doing some analysis and a little bit discussion. So for this part, I will pass this to another person to talk about the analysis of the graph that we obtained and the discussions from the graph. Okay.
Okay, my name is AIMAN Arif bin ABDUL GHAFAR and my metric number is 1181789. Now let's move to the results and discussion. So in this figure, you can see on the left is the graph of the results, and on the right is the explanation of the results. So in this simulation, Gaussian pulse is taken as an input signal as shown in the figure, and the optical Gaussian pulse generator with frequency of 193.1 THz and power of 0 dBm is connected after user-defined bit sequence generator in the layout arrangement for the simulation. The output is taken at a distance of 50 km, which is the fiber length. So this figure on the left shows the graph of dual-port optical time domain visualizer, which illustrates a relationship of power in watt against time. So the blue line on the graph is the input signal, while the green line is the output signal. So based on this graph, it can be seen that at time 0.18 nanosecond, the Gaussian pulse generator generates an electrical Gaussian pulse signal with input power of 1 milliwatt. However, the output power can be seen to be decreased to 140 microwatt. This is due to the dispersion after 50 km propagation through an anomalous dispersive fiber. Next, we move to the next result, which is the dual-port optical spectrum analyzer. So, this figure shows the graph of optical spectrum analyzer, which illustrates a relationship of power in dBm against wavelength in meter. So, based on the graph, it can be seen that at wavelength of 1.552 micrometer, the input power rises to negative 25 dBm. This is because at this wavelength, the Gaussian pulse generator generates electrical Gaussian pulse signal, and optical spectrum analyzer is used to display how an optical source power is distributed throughout a range of wavelength. It shows power in the vertical scale and wavelength in the horizontal scale. So based on the graph, we can see that the output signal produced is the same as the input signal because dispersion gives no effect to the magnitudes of the frequency components. Next, for the conclusion. So as conclusion, it is clear from the results that the dispersion affects the output power when the fiber length increases. So when the fiber length increases, the pulse broadens linearly and therefore cause the output power to decrease. However, the magnitudes of the frequency components are unaffected by the dispersion. And last but not least, in order to reduce the dispersion, it is necessary to use various techniques such as the dispersion compensation in a single mode optical fiber communication system. So the use of this dispersion compensation fiber can achieve compensation of the signal to eliminate chromatic dispersion. So that's all from us. Thank you.